Welcome. Thanks for joining us to an introduction to ZOS hybrid batch processing. I'm Steve Getz and I'm with Dovetail Technologies. What I want to do in this brief presentation is take you through a formal definition of what we mean by hybrid batch processing, give you a quick introduction to the Co-Processing Toolkit, take you through an example of how COSI implements hybrid batch processing via a Hello World example, and then give you some next steps to follow if you want some more information. So what is ZOS hybrid batch processing? These 5 principles make up what we refer to as sort of a formal definition of this technology. First of all, we have to have the ability to execute a program or a script on a virtual server from a ZOS batch job step. Secondly, the target program that we want to run may already exist and should ideally not require any modification for its execution. Third, the target program's input and output streams, the standard streams in other words, are redirected from and to ZOS spool files or data sets. Fourth, the target program may access other ZOS resources during the course of its execution. That is, it can reach back to ZOS and read DDs, datasets, POSIX files, and even run ZOS Unix programs. Fifth, the target program's exit code is adopted as the ZOS job step condition code so that we can easily track in our batch job stream what's happening on this remote server. Now, IBM doesn't offer any native software to provide this support, but the COSI Co-Processing Toolkit does. So let's talk about that briefly. In particular, there are 2 parts of the COSI Toolkit that implement hybrid batch processing. The first is the COSI Launcher. And what the COSI Launcher does is it starts a program on a remote server and it automatically sets up the plumbing to redirect the standard streams back to job step DDs. Once the program has been established and these streams have been redirected and the target program starts to run, it can use COSI dataset pipes commands to access ZOS resources for its execution, namely from DSN and to DSN to read and write ZOS datasets, from file and to file to read and write ZOS Unix system services files, and COSI Client, which is a generalized command that allows the target program to reach back into ZOS, run a ZOS Unix command, and then process its output on the remote system. Data security is also a consideration in the COSI Co-Processing Toolkit. It is implemented on top of the proven OpenSSH technology and uses OpenSSH for its network security. Resource access is protected by the job-owning SAF profile to provide good quality access to this remote to the ZOS resources from the target program. And then finally, by default, the data that the remote program transfers from ZOS for its processing is typically tunneled back over SSH for network security. However, in secure environments on the Z Enterprise, where we have networks like hypersockets and the IEDN, this tunneling can be turned off to provide much better performance in these secure environments without a loss of security. Finally, the COSI Co-Processing Toolkit is free to use. We have a community license that applies with very few restrictions. And if you are interested in commercial support licenses, we also have those available, and you can check with us for more details. Okay, so let's introduce our Hello World example. This is just a simple example that illustrates the principles of hybrid batch processing. What we're going to do in this example is we're going to run a program on a remote Linux server which is going to do a couple of things. It's going to write a message to standard out, and then in a pipeline it's going to read the contents of a data set on ZOS, and then using a program on the remote Linux system it's going to compress that data and then turn around and write the compressed data back to ZOS. Finally, the Hello World program is going to exit with a return code that will set the job step condition code. So let's get started. We need to have a ZOS system, which we show here on the right-hand side, and a Linux system, which we show here on the left. This is either Linux running on an IFL or Linux running on, say, a ZBX blade in a Z Enterprise environment. Next, we need a job, which we show here on ZOS. This is a typical looking job. We have a job card at the top and one step, which is called run. The job step executes the proc called cozy proc, which is a shorthand notation for the cozy launcher. And the cozy launcher requires the arguments about the user ID and the remote system that we're going to connect to. Next, we have a couple of DDs. Sysout DD is standard, and that's redirected to the job spool. Then we have a standard out DD, which is where our target program's standard out is going to be redirected, and that also goes to the sysout spool. Next, we have our input DD, which is the data that we want to compress using gzip. And then finally, we have the program that we're going to execute on that remote system, and that's specified by the standard in DD, and you can see it's a 5-line program that we're going to run. So when the cozy launcher gets control, it starts up, authenticates with the Linux system, redirects our standard streams for us, and then reads and starts to execute this program. Let's take a look at how that works. First of all, the program is moved down to our Linux system, and then it begins executing. The first line is an echo command, which simply writes its argument to standard out in a typical Linux fashion. The string that we want to write is hello $uname. Now $uname is actually another shell command, and we want to use command substitution for that, which means we run this little program uname, which gets us the name of the operating system that we're running on. Let's do that first. And of course, we are running on Linux here, not on ZOS. Now we have our string hello Linux that we want to write to standard out, and echo does its job and writes to standard out. But recall, the cozy launcher redirected standard out to ZOS, so instead of going to the Linux console, it goes up to our job log, just as we'd like. Next, we use a cozy dataset pipes command called from DSN to read the data from a dataset, which is identified by the input DD. Let's see what happens when we do that. From DSN reaches back to ZOS and starts to stream the data from my.data back to our remote Linux system. The output from DSN is written to a pipe, a Unix pipe, which is then piped into the gzip command, which with the -c switch says to start compressing the data. Gzip, when it's done compressing the data, writes its output to a pipe, which then goes to another cozy dataset pipes command called toFile, which writes its output to a Unix system services file called /tmp/out.gz. Let's see what happens when that starts to run. Let's take a look at what's going on here. So from DSN is actively streaming the data from the input DD, and as it's streaming the data, the gzip command is compressing that data and writing its output as it's compressing it to the toFile command, which writes its output to the Unix System Services file. Notice this is all going on in parallel. There's no data at rest. We don't have any temporary files. It's all happening at the same time. Eventually, from DSN finishes reading its data, gzip completes its compression, and toFile finishes writing its file up on Unix System Services. Finally, the target program wants to exit, and it's going to exit with a return code of 4. This is taken by the cozy launcher and used to set the job step condition code as we see here in the final diagram. Now let's take a look at this from our hybrid batch processing principles. Principle number 1, we were able to run a remote program, on a remote system. Principle number 2, we were able to use a program that already exists, which is gzip, without modification. Principle 3, our standard streams were redirected back to ZOS. Principle 4, our remote program was able to access ZOS resources. And Principle 5, the return code is adopted as the job step condition code. This chart just sort of has a textual description of what's going on in that previous chart, and it's here for your reference. So that's our introduction to z/OS hybrid batch processing. I hope it was useful. I'm going to recommend that you visit our website for more details. We have a solutions page that provides more information, and in particular we have a case study titled Updating a Linux Database from z/OS Batch, which provides a little bit more technical detail about how all these features work, and it's probably worth a couple of minutes of your time to check that out. Finally, if you have any questions, you can email us at info@dovetail.com. Thanks for your attention, and hopefully we'll be able to speak to you again soon.